What's up, everybody? This is Matt Brown with another IoT hacking video. Today we are going to discuss the fundamentals of capturing traffic from an IoT device, and we're going to discuss the tool that I have written to facilitate this data capture and just do an in-depth dive on that tool. So let's go right over to my screen to look at that tool. So you may have heard me talk about this tool, man-in-the-middle router, in a few of my previous videos, and today we're going to just do a dedicated video completely talking about this tool, going from a Linux system with a couple of interfaces on it to capturing data in Wireshark from an IoT device. So I have a camera that we've used in past videos over on the desk, and then that's going to be our demo for today of this tool. So first, let's talk about man-in-the-middle router, what it is. So it is a shell script, that's it. And it's just going to automate a bunch of commands that I have cobbled together to create this environment. Now this might look complicated if you're not familiar with some Linux networking concepts, so we're going to go step by step through this diagram and explain everything that's going on so we can capture all the traffic that our IoT device sends out to the internet. So the first thing I want to note about this diagram is that right down here we see this bit about man-in-the-middle proxy. We are going to completely ignore that for this video. That is for dynamic attacks where we are actually rerouting traffic that goes to encrypted endpoints out on the internet, and it's attempting to decrypt some of that traffic. We're not going to talk about that. That'll be out of scope for this video. So watch some of my other videos to see how we do that. But the fundamentals of what we're going to do is we're going to have some IoT devices. Now, IoT devices, some of them have Ethernet, and some of them connect via Wi-Fi. So we're going to have a system that will facilitate either of those two interfaces flowing through our system and capturing that traffic, and that can happen simultaneously if you set it up this way. Today we are just going to target a wireless device, so we're also going to not have the Ethernet interface actually exist in our current setup. So what's going to happen is we are going to have a wireless interface. So I have a USB wireless card, an alpha card, plugged into my Linux computer here, and that is going to show up as an interface right here. And then we are going to run host APD. That is an open source Linux utility used for creating in Linux a wireless access point. So that is going to broadcast, and we're going to give it information like the SSID, the encryption type, the password for the Wi-Fi network. So those are all user configurable within this script that we're going to talk about. And then once the IoT device connects to that wireless network, it is going to be bridged. It is going to be glued together to this bridge interface, which we are calling BR0, or as some of you in the YouTube comments in my other videos, you think I need to pronounce this as bro. So this is the bro interface. No, we're not going to call it that anymore. So we're going to connect, we're going to glue these two interfaces together to BR0. It's going to be like their one interface to the Linux system for the most part. And then on this bridge interface, we are going to run a program called DNS mask. DNS mask is going to act as our DHCP server. If you're not familiar with DHCP is, when you connect to a network, whether it's over Ethernet or Wi-Fi, you need to pick up automatically a local IP. Now you could statically assign your IP. For the most part, we don't do that anymore. We have a router on a network provide all the client devices a IP dynamically. And so DHCP is the protocol that gets used to do that. And so this is another open source tool in Linux that we're going to use that is going to hand out IP addresses to any device is connected over Wi-Fi or over Ethernet so that they will all be on the same local network. And so this whole left side of the diagram represents our LAN, our local area network for our man-in-the-middle setup. So then what we're going to do is we're going to have some IP tables rules. IP tables is a Linux-based firewall software that integrates with the kernel and all of the packet routing facilities. And we're going to use it to glue together the left side of the diagram with the right side of the diagram in our WAN interface. So this WAN interface, the WAN stands for Wide Area Network. It's the most of the time, like a router at your house, that's going to be plugged into the internet, to your internet service provider is what's going to be on the other side of that WAN interface. In my testing environment, it's actually another local network inside of my home network here, but that can be anything. And the scope of my program does not provide an IP address for this WAN interface. This program assumes that you already have an interface that is your WAN interface. So to put it really simply, on your computer, the WAN interface is going to be whatever computer, before you set up any of this software, it's going to be whatever interface already has an IP address and the one that you're using to get internet access. So that's going to be our WAN interface. And like I mentioned, there are some optional IP tables rules to reroute traffic down here to another program. We're not going to do that. So that part of the IP tables commands, we're going to see that that's commented out by default in our script. So that's enough of that diagram. So there are some dependencies. Based on your flavor of Linux, I run Arch Linux. I know I'm probably in the minority there, so you're going to have to figure out the correct package to install for whatever flavor of Linux you are using. I always tell everybody the best Linux distro to use for hacking is whichever one you're most comfortable with and whichever one you can get the most utility out of. And so you're going to need to install these 4 packages at a minimum: host APD, DNS mask, bridge utils, which is going to allow us to create these bridge interfaces and set them up, and then net tools, because my script does use ifconfig. Somebody made an issue saying, hey, why don't you use the IP command, the newer set of networking commands. I just use all the old ones. So obviously you could change up the script and make it use all the new stuff if you wanted to. That's just your choice. So we've done enough talking here. Let's actually go and grab this URL, and then I'm going to go over to my shell here. Let's make this a little bigger, and we're just going to clone that repository into a directory, and now we're going to cd into man-in-the-middle router, and there we see all those same files. Now, to get this set up for our system, because I don't know the interface names that you want to use for the WAN and the LAN and all this stuff, right? We need to go and edit this script. It's a shell script. It's just a text file, so you can open it in whatever text editor you feel most comfortable with. And we're going to, at a minimum, we're going to have to set the WAN interface, and then we're going to have to set the LAN or the Wi-Fi interface here. Like I said, in my example, we're just not going to be touching the LAN. This is the Ethernet interface. And so what I'm going to do on my computer is I'm going to open up another shell here, and we're going to run our ifconfig command, and here is the really crazy long name of the wireless interface. Again, this is a USB wireless card that I have plugged into my computer over here. And so I'm going to set that as the wireless interface name. And then the WAN interface on my network is going to be this one. Again, you should be able to look at this and see, oh yeah, that's the IP that's on my local network that my actual router that you use normally handed out to me. So And then what you're also going to have to check is if for some reason you happen to have this IP space here, you're going to have to change up the this subnetting. So by default, my script is going to make that bridge interface. It's going to make it run on a 192.168.200 star network /24 network there. So if that conflicts, if you happen to have that same exact IP space set up at home, which you probably don't, you are going to have to change either your network or you're going to have to change my network here in the script. But here we go. We can set our WAN interface. And again, it's going to complain that this ETH1 interface doesn't exist, but it's not going to cause anything bad to happen. The wireless interface will still work just fine. And then this BR0 interface, if you wanted to change the name of that, that doesn't matter. And then, and then here are some other really important variables you might want to change: the SSID and the password. By default, we're going to go through this whole script, but by default, it's going to use WPA2 encryption to set up that wireless network. So let's get this out of the way so we can, whoa. I can't type today. All right, demo. Here we go. Oh, I know what I did wrong. I full screened it. That's what we did. And we're back. All right, cool. So here we've got our script. We are going to go through this line by line and explain everything that's going on. That's the whole point of this video. You can just blindly run this script and hope that it works, but I hope you learn a little bit of something about Linux networking and how I'm gluing all this stuff together, and that will hopefully help you when you need to make one little tweak to it to know how to make those tweaks. So, like we said, all these variables are going to make sense further on down the line. So we are going to set up that local network side, the LAN side, to have this IP address as our router, our gateway. That is going to be its IP address. And then this is going to be its net mask. And then here we have some settings for the DHCP server. So we talked about that DHCP server that's going to hand out IP addresses to all of our IoT devices that connect. So this is just defining the range of IPs that it's going to hand out. I always like to leave a few at the beginning because in case I want to statically assign some IPs at the beginning of the range, you can do that. Completely your preference. And then I'm just going to hand out the Cloudflare 1.1.1.1 as the DNS server, again, through DHCP. That's how most devices get their DNS server. It's not hard-coded on the device. It will accept whatever the DHCP server gives it. So here we're going to scroll down and we're going to talk about this script. So here we just have in Bash, it's going to pull in an argument. So this script takes in one argument, up and down. Up is going to turn on the man-in-the-middle router, and it's going to set everything up nicely. Now, when you hit Control-C, it will kill the wireless network, but a lot of the other stuff that this script builds up and sets up, it's still going to be there. And so the down command is going to nicely deconstruct all of the networking things that we're going to build in this script. So, yeah, let's keep going down here and let's see. So here, because this script can be run multiple times, I'll talk about why you'd be running it a bunch of times in a row. But every time you tell it to run with the up command, it's just going to kill everything and it's going to start over. So, we instantly make sure that WPA supplicant and DNS mask are killed on the device. And so then what we're going to do is we are going to set, first we're going to reset all the network interfaces. So the LAN, the bridge, the Wi-Fi interface, and then we're actually going to delete the bridge interface itself. And then here we say if our argument to the command was up. So if we sent the up command to man-in-the-middle router, then we're going to do all this stuff, right? So here we're going to create a DNS mask config file. So here we're just setting up all the settings in DNS mask. We're saying, what interface do you run on? It's going to run on the bridge interface. What's the DHCP range? That is that start and end value that we see in the variables up at the top. This DHCP option 6 specifies the DNS server to hand out, which we talked about. We're giving it the 1.1.1.1 IP address. That is our DNS mask config file. That will get DHCP in a place where it's good to go. Next, the host API, or that's just building the config file. It hasn't actually run DNS mask yet. It's just the config file. Now we're going to set up the host APD config file. This is to create that wireless network. And here's where I was saying, by default, we are going to spin up a WPA2 network, and then the passphrase is going to be the passphrase that we sent in. By default, it's going to run on channel 11, so it's going to be a 2.4 gigahertz network, not a 5 gigahertz network. Obviously, you can go in here and you can change that. If your IoT device does something weird and different that you want to test only on 5 gigahertz, for some reason, most IoT devices, if they only support one band, it's going to be the 2.4 gigahertz band. But if you have some weird device and you need to spin up a different network, this is where you're going to make those config changes right here. Scrolling down some more. So this is an option that I have turned off by default, but this is something I like to do in IoT pen tests sometimes, is I like to test if the device will actually connect to the router if I have protected management frames enabled, which causes the management frames and Wi-Fi, which include deauthentication packets, to be encrypted, to be authenticated on that network in WPA2 mode. In WPA2, protected management frames is optional. In WPA3, like actual pure WPA3, not the fallback version of it, it is required. So that's sometimes an edge case that I like to suss out in pen tests. And I've received bug bounties for that, so free tip. All right, so then we're going to, all those interfaces that we brought down, we made sure we're down, we bring them all up. So every interface, the Wi-Fi, the WAN, the LAN, the bridge interface. So we're creating the bridge interface, and then we're adding to the bridge interface the LAN interface. And so, yeah, good to go. All right, and so, yes, I was like, why do I not add the wireless network? That's a good question that I just asked myself. So the reason why I don't add, so here I add the LAN, which is the Ethernet interface. Couldn't have named that a little bit better. But why don't I add the Wi-Fi network? Well, because host APD automatically adds itself to a bridge. In fact, you're actually specifying like the bridge interface right here. And so host APD itself will manage adding this interface, this Wi-Fi interface, to this bridge interface. So we do not take that step ourselves in a command similar here like we do to the Ethernet interface. Just answer my own question. All right. So then we set up IP tables, right? So IP tables is going to glue these two networks together. So the first thing we do is we flush, we just clean out all of the IP tables rules, and then we're going to set up this one. This is going to be masquerade. So this is going to set up the, these two rules actually. So these two rules right here, all these, what they're going to do is they're going to set up the NAT. They're going to set up a network address translation that's going to occur. So when a packet goes out of the LAN, it's going to masquerade as the gateway. It's going to translate the source IP from the IoT device on that little local network to the IP address of our network itself on the WAN side. So that way, when that packet gets shipped off to, you know, my ISP's router or whatever gateway is upstream, then when the packet comes back, when the response comes back, it knows where to route it to. So that is what we're doing with these IP tables rules right here. That's what that's setting up. And then right here, I say optional man-in-the-middle rule. So optionally, what we can do is we can redirect based on some set of criteria. We can redirect to a port locally on our machine where we would be running some sort of SSL intercepting proxy. Again, we have that commented out for this video. We're not going to go into that in this video. I touch on it in other videos. Definitely go and watch those. Moving down, almost done. So what we do right here is we set a static IP on the bridge interface. And so that IP is that LAN IP, right? So up here, it's this IP right here that we're going to set onto our bridge interface, because that's what we want to have the IP, right? We don't want to set it on the Ethernet or the Wi-Fi interfaces. If we only were doing Ethernet or only doing Wi-Fi, we could technically get away without having maybe we could get away without having the bridge interface. We could in the Ethernet case. Host APT probably wouldn't like us bridging to a not bridged interface, but I'm not 100% sure. Don't quote me on that. But we are going to set it on the bridge interface instead of the Wi-Fi or Ethernet. And then we're going to start up our services. So we're going to start up DNS mask. That's our DHCP server. And then we start the access point itself. Again, referencing those config files that we built in those commands above. And that is the end of our script. And so at the end of all of that, what we get to do is we get to run the up command, and it will bring up the Wi-Fi network. Again, it's going to yell at me here somewhere. Where is it? Maybe. Oh yeah, right here. It's going to yell at me and tell me, hey, like this ETH1 doesn't exist. I didn't really configure that. Again, you only have to have one of them configured. And here you can see though that the AP is enabled. So now that access point with the SSID and password that I configured in the script is running. And so now I'm going to turn on my device, and I'm going to come over here in Wireshark, and I'm going to listen on the bridge interface. Okay, so I'm on the bridge interface. Sweet. Okay. And here we can see, that was good timing here, we can see packets. So we are getting packets from our IoT device. So this IoT device was already configured to connect to this preset inside of the script. I don't want to stop the script. So it was configured to connect to the SSID of CTech Astronomy and the Wi-Fi password of my password. Super secure, right? All right. If you can get in Wi-Fi range of me and hack this test network, go for it. Good luck. But now we are able to get all of the packets, all of the data that device sends up to its various cloud servers, anything out on the internet. We get to see it all here in Wireshark. And that is the accomplishment of the goal of this tool. So I want to thank you for watching this video. I'm going to do another video soon where we take the next step of talking about Wireshark and what we actually look for inside of Wireshark when we're trying to analyze what data an IoT device is shipping out to the world. So stay tuned for that. Please like, comment, and subscribe. I appreciate all your guys' feedback. Definitely check out the Discord. There's lots of collaboration, group projects going on. Thank you for watching this video, and have a good day.